Hey, algebra students, in this lesson we're going to be talking about higher order roots. Now, when I talk about roots, I'm talking about the number that I need to multiply by itself to make a different number. So, for example, you'll see letter A down here, the square root of 196. We're asking ourselves, what number do we need to multiply by itself to make 196? That is a square root. For a square root, it's just the number multiplied by itself one time. So really, we have two of the numbers multiplied together as factors, right? Square root of 196 is 14 because 14 times 14 equals 196. So 14 is expressed two times because it's multiplied by itself, right? That's a square root, but that's not a higher order root. A higher order root means that we could take a cube root with a little 3 up here instead of a 2. So square root uses, technically there's like a little implied number 2. Let me just put it in for you, okay? So it's like we imply that there's this tiny little number 2 that's right here next to the square root sign. But for a square root, we've just kind of decided as mathematicians, you don't actually have to put that little 2 in. We're just going to assume if you write the square root symbol without a little number up here, then that just means a square root. What number multiplied by itself? When you see a little 3 or a little 4 or 5 or 6 or 10 or 12 up there, what you're talking about is a higher order root. So this one down here is asking, what number do you need to multiply by itself 3 times to make negative 343? What number do you need to multiply by itself 4 times to make 160,000? Okay, so that's the difference between a square root and a higher order root. A square root is just multiplying by itself one time, so that there's two of the numbers, 14 times 14. We multiplied 14 by 14 one time. Here, we're multiplying a number by itself. So we're multiplying the original number 3 more times for a total of 4 numbers. So if I have 4 numbers in a row multiplied together, what number would I have to use to make 160,000? That's a higher order root. Higher order roots can be expressed by writing the square root symbol that we're used to, but then putting the actual root, not the square, not the 2, but whatever root we're looking for up here, okay? And then it's just asking if we multiply a number by itself this many times, n times, what number do I have to multiply by itself that many times to get the number under the square root symbol, under the higher order root symbol in this case? Now, here's the other tricky, cool little thing we can do. Higher order roots and even square roots can be expressed with fraction exponents, okay? So the square root of b is the same as b to the 1/2. Now, we've dealt with 0 exponents. Anything raised to the 0 is 1. When we did that lesson, you kind of got the sense that exponents, when they're not like positive whole numbers, they're kind of funky. They do kind of funky things. When you raise something to the 0, it's 1. That seems really strange. When you raise something to a negative exponent, it means it's on the wrong side of the fraction bar. So we've done negative exponents. Now we're going to see what happens when we do fraction exponents. When you have an exponent that's a fraction, instead of raising the number to a power, you're going to take the root of a number. So 125 to the 1/3, and yes, that says 1/3. I know it's a little blurry. 125 to the 1/3 is actually expressing what is the cube root, the third root of 125. All right, let's do some problems. A, B, C, and D are all extremely easy. So A is 14. We already did that one. B, I have to take the square root of 64 and then make it negative. Notice I have the square root symbol here. By the way, in order of operations, taking a square root counts as an exponent because it's an exponent-related problem. So we have to do the square root first, and then we can do the negative sign. So square root of 64 is 8. And then I'm going to make that negative. We get negative 8. The square root of 1, what do I multiply by itself to get 1? 1. Okay. And then here's a tricky one. The square root of negative 64. I can never take an even-powered root of a negative number. Because I noticed the difference up here in letter B, the negative was on the outside. So I did the square root first and I just applied the negative. Here, the negative is under the square root symbol. In this case, the square root symbol is acting kind of like a grouping symbol. And I have to do what's underneath the square root symbol all together, and then take the square root. I have to take the square root of negative 64. Hey, what number can I multiply by itself to make negative 64? What number could I ever multiply by itself to make a negative? Think about that for a second. I multiply a positive and a positive, I get a positive. I multiply a negative and a negative, I get a positive. So there's no number that I can multiply by itself to get a negative. To get negative 64, I need to multiply like 8 and negative 8, but that's not the same number twice. If you have a negative value under a square root symbol, the answer is always going to be undefined. Okay, and that applies for any even root. So a square root, a fourth root, a sixth root, an eighth root can never be negative, because when I multiply a negative an even number of times, it's always going to be positive. All right, let's take a look. What do I do with fractions under the radical? Well, this is really easy. I just take the square root of the top and the square root of the bottom. Square root of the top, square root of 81 is 9. Square root of 144 is 12. This answer is going to be 9 over 12, which can be reduced to 3 over 4. Ooh, here we get a hard one. I don't know off the top of my head what the square root of cube root of 1,728 is. In fact, I have very few cube roots memorized. But you can use a calculator to figure out more advanced cube roots. 1,728. So let's go to a calculator. We're going to do 1,728. Now, how do I type this as a cube root? Well, the easy way is to raise this to the 1/3 power in parentheses. Because remember, the cube root of something is the same as raising to the 1/3 power. So if I do this, I get 12 as my answer. Let's just make sure we did that right. I could do that with any of these higher order roots. What about negative 343? I don't know what I have to multiply by itself. Now, here's one way you could do this. 343 is a pretty small number. I wonder what 9 times 9 times 9 is. Let's see if we can do 9 times 9 times 9. 729. Okay, so that's too big. I know it's not going to be 5. Let's try 7 times 7 times 7. 343. I figured it out. 7. Now, negative 343 can be found by multiplying negative 7 times negative 7 times negative 7. Negative 7 times negative 7 is positive 49. Positive 49 times negative 7 is negative 343. Now, here's the thing. If I have a negative under a root and it's an odd numbered root, it can be solved, because a negative times itself 3 times is going to be a negative number. So odd numbered roots, it's fine to have a negative underneath. Even numbered roots won't work. How do I find the fourth root of 160,000? I know this is going to have to do with the number 4. I'm guessing it's going to be, or no, maybe not. Boy, this is kind of a hard one to figure out too. But all I have to do is find a calculator and do 160,000 to the, the fourth root, so it's going to be to the 1/4. The answer is going to be 20. Okay, 20 times 20 times 20 times 20. Now, I could have tried to guess. For roots of numbers that are in the thousands, I would always recommend using a calculator, because otherwise you're going to be guessing and checking for a while. 20 times 20 times 20 times 20 is 160,000. All right, the fourth root of negative 16. I see that this is going to be really easy. I don't even have to do the problem. I have a negative under an even root. That's going to be undefined. What would happen if I tried to do that? So if I tried to do, what was it? The fourth root of negative 16. So I have to put negative 16 in parentheses to the, and then 1/4. And let's see if it even does it. It's going to give me some really, really strange answer, okay? This doesn't look like a normal answer. Some calculators will just say undefined. Some are going to try to give you this really strange answer. We'll learn about this kind of an answer in pre-calculus class. So don't worry about that yet. Just know that if it's the even root of a negative number, it's undefined. Okay, over here. What number times itself 3 times is 125? This one I know off the top of my head. 5 times 5 is 25. Times 5 is 125. So this one's just going to be 5. 5 times itself 3 times is 125. This, by the way, is to the 1/3. That's the same as the cube root of 125. The cube root of, can we do a cube root of -8? Yes. 2 times 2 times 2 is 8. -2 times -2 is 4, times -2 is 8. -2 is the answer here. Can I do the fourth root of 81? Well, I'm okay. So again, 81 to the 1/4 means the fourth root. What number do I multiply by itself 4 times to get 81? I'm guessing it's going to be 3. Let's just try that out. 3 times 3 is 9, times 3 is 27, times 3 is 81. You'll notice that when we're dealing with fourth roots, fifth roots, third roots, and especially if the number is a 2-digit or a 3-digit number, usually we end up with really small answers. So the fourth root of 81 is just 3, because when I multiply 3 by itself a number of times, it grows to a big number very fast. And then the fourth root of -625. Well, here we have a negative number with an even numbered root. So this one's also going to be undefined. I cannot do an even root of a negative number. And then let's see. The sculpture in the shape of a cube has a volume of 1,728. What is the side length of the block? Here I'm just going to take 1,728 and the cube root of it. Okay, so to the 1/3, that gives me 12. Oh, hey, look, we already did that in letter F. So if I have a cube and I need to know the length of one side of the cube, I just take the cube root of the volume, and that gives me my answer.